Hello guys, as you have already seen before, like what are the steps that I can use to push an element into the stack is first I'll initialize my top value to be -1. So what is this top? I'll take a temporary variable top and I'll make sure it is pointing to the bottom of my stack, which is the position of -1. Okay, like it is pointing to the bottom of my stack. And I'll check for overflow condition whether my top is equals to n minus 1. So what is n minus 1 here? It is here. See, it is top of the stack. This is my n minus 1. As the value starts from 0, 1, 2, 3, 4, etc., it falls up to n minus 1. Okay, where n is the size of the stack, like capacity of the stack that can store, number of elements that can be stored into the stack. If suppose if I'm taking 5 elements, like what is my topmost value will be like n minus 1, that is 4, right? Okay, this is about topmost element value. Now we'll check whether it is whether my top value is equals to this n minus 1. If it is n minus 1, my stack is overflowed, like I can't insert any further extra element into this stack, right? I can't insert further element into the stack if it is overflowing condition. Clear? So we'll check the overflow condition. If it is overflow, we'll just print the user that my stack is completely filled and there is no space left to insert an element. Okay, clear? Otherwise, if it is not overflowing, like I have some space. If suppose if I have only 2 elements into the stack, still I have place to insert the element, like still have this much place, still I can store 1 or 2 elements into the stack. At that position, what we'll do, we'll just simply increment the top value. Okay, top is always pointing to the topmost element into the stack, which is in the stack. See, now what is my topmost element here? This is the topmost element, that is second element. So when I increment the top value, it is pointing here. So when I just increment my top value, it is something pointing here, right? It goes right. So in such a way, we're gonna perform the operation called pushing. Okay, first we'll initialize the variable top with the value -1. Okay, we have done. We'll check for the overflow condition. We have checked, it is not overflowing, as my top is now pointing here. Okay, it is not overflowing. Okay, if it is overflowing, we'll just stop the process here. We'll say the user that stack is overflowing. After that, what I'll do, I'll just increment the top value with +1. Okay, like +1, I'll increment my top value, as now there is some what element, so it is pointing, my top value is pointing here. So in this way I can insert an element. Yeah, these are the steps that you can follow to insert an element. So now let us see what are the procedures to delete an element. So when we delete an element into the stack, when we have some elements, then only I can delete, right? See, suppose this is my stack with 3 elements I have. I want to delete first element. Okay, if I want to delete, first thing is I want to check for underflow condition. What is my underflow condition? Underflow condition is like my top is under, like here it is, my top is here. Okay, I'll check whether my top is equals to -1. If it is -1, that means there are no elements in the stack. So that's what my top value is pointing to, the -1 value, -1 position. Here it is pointing, because there are no elements in the stack only, then only my top value will points towards the -1 position. If it is pointing to -1, that means that there are no elements in the stack, that is my stack is in underflow condition. Okay, first thing is we'll just check the values top equals to -1. If it is being equal to -1, then I'll say user that my stack is underflow. I don't have elements to be deleted. I'll just simply display to the user. If not, see here, let us say, take the values for a better understanding. 0, 1, 2. Okay, clear? This is my n minus 1. This is for overflow condition, and this is for underflow condition, which is minus 1. Okay, so we'll check whether my top value is equal to minus 1. Now where my top value is pointing, it always points to the topmost element. Which is my topmost element? This one, right? So what is the value of my top? Now 2. Is it equal to minus 1? 2 is equals to minus 1? No, right? It is not equal to minus 1. Okay, I have checked this underflow condition. It is not underflow. Then I'll go to step 2, that is top minus minus. So it is not underflow. Then what I'll do is I'll just decrement the top value. Like 2 minus 1, it becomes to plus 1, which is the back element. Now my top is pointing to the first position element, that is this one. It is pointing to this element. So as we know, top is always pointing to the topmost element. This means that this element is deleted. Okay, practically or logically it is not deleted, but we'll just estimate that there is no such element, as my top value is pointing to this element. This is only my topmost element. Okay, in which position your top is pointing, that is only your topmost element. Okay, now my top is pointing to this element, so this is my topmost element. So this is about deleting. We'll just check the underflow condition, that is top equals to minus 1. If it is underflow, we'll just stop the procedure and we'll say the user it is underflow. Else we come to the second step, which is decrementing the top value. Simply, like I can decrement the value. Every step I'll check the underflow condition. For every step I have to do, because once we are decrementing, it may fall under 0, or else it can come to minus 1. Okay, which is my underflow. So for every step I have to check underflow as well as this overflow condition as well, for each and every step, for each insertion and deletion. Okay, this is about inserting and deleting. And now we're gonna see how do I display the elements in the stack. Suppose I have performed these operations, right? Now we're gonna see what are the elements in the stack. Okay, what are the elements in the stack? So for this, I'll just make use of a for loop, which has variables like integer I value. I'll be declaring it, and I'll give the value of this I to be my top. Let us say, now you say the values. It is 0, it is 1, and it is 2. So my top is always pointing to the topmost element, which is this one, right? Which is this position. This position my top is pointing. So what I have done in this showing of elements, I have given the value of I equals to top. That means what is my value of top here? 2. So I am giving the value 2 to my I. I equals to 2. Okay, I have given. What is next step? I'll just see whether I is greater than or equal to 0. So 2 is greater than or equal to 0? Yes. So when it is yes, it directly goes to the implementation part. Then the value will be implemented. Okay. So I have checked the second condition. So I'll go to the loop, which is print the stack of top. So what is my top? Top, I'm not changing any top. Okay. First, I'm just giving the top value to I also, but I'm not decrementing or incrementing top value directly. Okay. This is the step when we implement. After implementing this part, we're gonna implement this one. Okay. First the working of for loop is just to check this condition and this condition and enter into it. After implementing or executing this area, then I'll gonna perform this decrement or increment operation. Okay. So I have given the I value, I have checked I value. Now I'll print the stack of top. What is my stack of top? The element which is at this position, right? At this position, the value at this position will be printed to the user. Okay. After printing, what I'll do? Again I'll go Okay, again now what I'll do is I'll just decrement the top value. What's my top value now? 2. I'll decrement by 1. That means my top is now pointing here. Okay, my top is now pointing here. Okay, let us take it. So again I equals to top. What is my top now? 1. So now I'll give the value of I equals to 1. I'll check whether I is greater than or equal to 0. So 1 is greater than or equal to 0? Yes. So again I'll print the stack of top. What is my stack of top? This element, right? Stack of 1, which is this element. Okay, after printing, what I'll do? I'll decrement the top value. What is my current position of top? 1. I'll decrement by -1. It becomes 0. Now my top is pointing to this element. Okay, after pointing to this element, top becomes 0. So okay, these actions are performed. Now I'll go to the first step again, that is I equals to top. Now my I equals to 0, which is top, right? What is my value? I is 0. So after this, what I'll do? I'll just check whether this condition is being satisfied or not. I is greater than or equal to 0. I is 0 or it satisfies this condition, right? I is greater than or equal to 0. It is 0. Okay. After this condition, what I'll do? I'll just print the stack of top. What is stack of 0? This element, right? This element I'll print to the user. Okay. And then after this, I'll just go to this decrement part, which is top minus minus. That means top is now pointing to -1. Okay. After this, I'll again perform this part. I equals to top. So what is my I value now? I equals to -1. Now I'll check the condition -1 greater than or equal to 0. Is it satisfying? No, it is not true, right? It is not greater than or equal to 0. So now my condition get false and there is no execution of this step. Okay. So I have already printed this element to the user, this element to the user, this element to the user. I have printed whatever the elements in the stack to the user. I have displayed all the elements. Okay, hope you are clear with this. So these are the steps where you can perform push operation, deletion and display of the elements. Hope you are clear with this. Yeah, thank you.